Hi everyone, in this video we're going to be looking at measurement of rotation. We're going to see what happens when we put angles on a coordinate plane. And in order to see what I'm talking about in terms of the coordinate plane, we first have to understand what standard position is. So again, we're starting off here today with measurement of rotation. That's the general idea of what we're doing. So I'm just going to write that on top here, measurement of rotation. And the first thing that we have to understand is what standard position is. All right, so an angle is in standard position. On the coordinate plane or Cartesian coordinate system. Plane if, and here are the criteria. So it's in standard position if, I'm just going to make like a bulleted list now, if the vertex is at the origin. And remember that the origin is the point 0, 0. If the initial side, and I'll go over what initial side is in a minute, is along the positive x-axis. And if it is measured counterclockwise from the x-axis, again it's the positive x-axis, if the angle is positive, and clockwise if the angle is negative. So we will have negative angles now. I know that's not something that you're used to, but because of this direction that we could put it in now, we could have negative angles. So I'm just going to draw a quick angle here to tell you what initial side is and stuff like that. So here we have a fixed point, so that's the vertex. And if I'm measuring the angle from here to here and I call this theta, then this is the initial side. And this is what we call the terminal side. Those are just some terms for angles. So now I'm going to actually start drawing things on the coordinate plane in standard position. So I'm going to go on a new slide now. Okay, say I wanted to sketch 60 degrees. So I'm going to start off with my coordinate plane. So this is my coordinate plane. I always start my angle from the positive x-axis, so right here. The vertex is at the origin, so 60 degrees would probably be somewhere around here. Okay, so that's my angle from here to here, that's 60 degrees. Okay. I know that from here to here, because this is a coordinate plane, this is a right angle, so from here to here is 90 degrees. And if I kept going, if I went from here all the way to here, that would be 180 degrees. If I went from here all the way to here, that's going to be 270 degrees. And if I did one complete revolution here, that's going to be 360 degrees. 360 degrees could also be considered 0 degrees because if I just have this angle here that I didn't go anywhere for, that's 0 degrees. So going along here, I have again 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 if I went full rotation. So what that means is if I wanted to draw something, let's say, I'm doing it over here now. Let's say I wanted to do 240 degrees. So now 240 degrees, I'm going to have to figure out what is it in between, or what quadrant should it be in. So 240 degrees is between 180 and 270 degrees, so I know it's in quadrant 3. And I know it's probably a little bit closer to 270. These sketches aren't going to be perfect, so it's around here. So from here to here is 240 degrees. You always need this. So you see how I was drawing like an arrow? You always need that when you're sketching an angle to show the measurement of rotation, right? Because if I didn't show this, then technically the angle could have been this, or I could have went around twice to land there, okay? And that's no longer 240 degrees. Only the original one that I drew was 240 degrees. So you always need to show the terminal side, and you need to show the measurement of rotation, so this arrow showing what direction it goes in. Now let's look at negative angles. So first we'll start off with the general. So negative angles, I said, go clockwise instead of counterclockwise like I was doing before. So that means for in terms of quadrant angles, you're going from here to here now, so this is going to be negative 90 degrees. From here to here is going to be negative 180 degrees. From here to here is going to be negative 270 degrees. And from here all the way to here is going to be negative 360 degrees, but also remember that that's also 0 degrees. So if I wanted to sketch the angle negative 120 degrees, I have to first figure out what it's in between. So if you want, when you're doing this in the very beginning, it might be good to label the quadrant angles, like label it with these things for reference on where to put your angle. So negative 120 degrees is also going to be in the third quadrant. I don't know why I keep making them in the third quadrant. It's right here. So from here to here is negative 120. Again, it's not perfect. What we need to see is your terminal side in the right quadrant and this measure of rotation arrow. Okay, and that's everything you need to know about standard position and sketching angles. Now I'm going to go over coterminal angles, which is another thing that you need to know. Coterminal angles are angles that land in the same spot. So I'll give you the definition first, and then I'll tell you two angles that are coterminal. So coterminal angles two angles are coterminal if and only if. So two angles are coterminal if and only if their degree measures, that was completely wrong there. Their degree measures differ by a multiple of 360 degrees. 360 degrees because that is a full rotation, and remember before I said coterminal angles land in the same spot, so their terminal side is going to be in the exact same location. So how we can write this out mathematically is that angle A and angle B are coterminal if and only if, that's just the notation for if and only if, abbreviation if you will, angle A equals angle B plus 360 degrees n, where n is any integer. So if I asked you for a coterminal angle to, let's say, 45 degrees, just anyone in general. There's an infinite amount actually. If I just want one, then I could just add 360 degrees, right? and that's going to be 405 degrees. So that means 45 degrees and 405 degrees are coterminal. And let's just double check that on the coordinate plane. So 45 degrees would be here. And 405 degrees is going to be one full rotation, right, all the way to 360, and then another 45 degrees. So it ends up right in the same spot. Okay, and those are coterminal angles. The last thing you need to know, and I could ask you for like negative coterminals too, so if I wanted a negative coterminal angle that with 45, you would just subtract 360. Again, we're just adding and subtracting 360 degrees in multiples. So it would be 45 degrees minus 360 degrees, which would be negative 315 degrees. That would land you in the same spot. I'll just do that really quick. So negative 315 does land you there. Okay, the last thing we need to know again is reference angles. Okay, so reference angles are the angle that the terminal side of an angle in standard position makes with the x-axis. So let me write that out and then show you what I mean. So the reference angle of an angle in standard position is the positive acute angle between the horizontal axis, so the x-axis, and the terminal side. So if I want the reference angle of 150 degrees, I would first sketch out that angle. So 150 degrees is in quadrant 2, right there, right? It's between 90 degrees and 180 degrees. The reference angle is going to be the angle that it makes with the x-axis. So from here down, that's the reference. This was 150 degrees, and from the positive x-axis to all the way over here is 180. So that means that little reference angle there is 30 degrees. So the reference angle of 150 is 30 degrees. And we'll do one more of these. Okay, let's say we want the reference angle of 320 degrees. So we're gonna sketch this out. 320 degrees is in the fourth quadrant. Okay, we know to get to here is 360. So that means this piece here is 40 degrees. So the reference angle is 40 degrees. Okay, one more. What if we want the reference angle for the angle for 600 degrees? So now we're going to be here. All right, 600 degrees, that means I go a whole 360, and then I go another 240. So that puts me in the third quadrant. okay? And I'm going to reference back to here, to the 180. So from here to here is 60 degrees. Okay, right? Because I know I went a full 360, and then I had to go another 240 to get here. And then the 240 here from 180 is a difference of 60, so the reference angle here is 60 degrees. Let's just do one negative one really quick, and then that'll be the end of this video. Okay, so what if I wanted the reference angle of negative 45 degrees? So you would just sketch your negative angle. So negative 45 is down here. And then the reference angle from here to the positive x-axis. For reference, remember it's just to the x-axis, but here I'm at the positive one. So that's 45 degrees. So the reference angle of negative 45 is just 45 degrees. Okay, so that's standard position, coterminal, and reference angles.